Again, it's going to take us a little second here to get to the Elmo. We're starting at number 20 now. So it should pop up here any second, and we'll begin. If you want to, you can fast forward about 10, 15 seconds. Here we go. We're there. So it says give the domain and range of the function. So if I look at my domain, it's my x values here. So it looks like it goes clear over here to -3 and then goes to 2. So it stops. So it's from -3 to 2. So this one has a domain of -3 to 2. This one has a domain -3 to 2. This one has a domain. This one does not. So B is already out. Now let's look at our y values. So the y values go down to -2 up to 4. So this only goes from 0 to 4. This one's out. This one goes from -2 to 4. This one is in. This one is out because it went from -3 to 6. So we are there, C. 21. 21 says, right, what is the intercepts of our exponential function shown below? Well, it looks like it crosses the y-axis. So that's going to be a y-intercept at 0, -2. And it looks like it crosses the x-axis for an x-intercept at 1, 0. So it says the x-intercept is 1, and there's no f of x-intercept or y-intercept. So A is out. The f of x-intercept is -2, so the y-intercept is -2, and there's no x-intercept. That's out. The x-intercept is 1, which is true, and the f of x-intercept is -2. That's true. The x-intercept is -2, false. There we go. C is our answer. Let's go look at number 22. 22 says, which statements are true about the graph of the exponential function f of x? So, it says the domain is all real numbers. So, that's true. A is true. It says the range is all real numbers. Ooh, that is false because look, it only goes down to -1. It doesn't go below -1. It just goes down to, but not including -1. It says the f of x, which is the y-intercept, is 3. Y-intercept is 3. That is true. It says the x-intercept is 1. Well, that's not true because here's my x of 1, x-intercept at 1, and it doesn't cross there. It looks like it crosses at, oh, you know what? That looks like a full class ticket. Pay attention. It looks like these ones are counting by 2's on the x-axis. That is a 1 right there. So that is actually true. That's a little tricky. That was stupid, but tricky. Okay? As x increases without bound, meaning as x goes to -infinity, f of x approaches but never reaches -1. That is true. As x goes without bound, increases without bound, that would mean this way to infinity, this value is going to -1. That's true. As x decreases without bound, that would be this way. As x is approaching -infinity, then f of x decreases without bound. Okay, no, f of x isn't going down, it's actually increasing. That one is false. Okay, turn the page. On to number 23. So 23 says the Bengal Bank pays 5.1% annual interest compounded quarterly. The Donut Bank pays 5%. Which bank gives a better interest rate? Okay, compounded continuously. Well, if we're looking for the rate, we really want to take a look at the equation f of t equals a times b to the t. We really want to get it into here because then we'll be able to determine from b, because remember b equals 1 plus or minus the percentage rate. From here we'll be able to determine the percentage rate. Based on this one here for the Bagel Bank, we get 1 plus 0.051 over 4 to the 4t because it's compounded quarterly. That 4 right there is there. So now, if I look at just this portion right here to the t, remember times is a power to a power, so I could look at this right here, which would then give us b, because b is to the t. So if I look at this right here, it gives me b. So I take my calculator, I turn it on, I'm going to type in parentheses 1 plus 0.051 divided by 4 into parentheses to the 4th power. and I get out 1.05198. I'm going to go all the way out to that. So this is 1.05198. Now let's look at the continuous compound. So continuous compound would look like this. E to the 0.05 t. So now, again, if I just look at the e to the 0.05, that'll tell me what b is. So this is b for this guy. This guy's b. I again take my calculator, do second ln, which is e to the power 0.05, enter, and I get 1.051271. If I subtract 1 from both of these, that'll give me my interest rate. So this guy's interest rate over here is 0.05198, or in other words, 5.198%. By subtracting 1 here, I get out 0.051271, which is 5.1271%. Which one is better? This one right here is better. So this guy here that's going quarterly is giving us the better percentage rate. Move to 24. 100 milligram sample of certain material decays at a continuous rate 0.1%. 100 continuous e to the negative 0.001 t. There's our equation. How much material will be left after 5 years? 100 second ln, which is then e to the power negative 0.001 times 5. I get out 99.501, and that's in milligrams. How long will it take the material take so that there's only 30% left? Well, if I look at it, I started with 100 milligrams. 30% of 100 milligrams would be 30. So the question is, when will 30 equal 100 e to the negative 0.001 t? Divide by 100. This is 0.3 equals e to the negative 0.001 t. In y1, clear out whatever you have, and then put in 0.3. And in y2, put in e to the power, so second ln, negative 0.001 x. Okay, hit graph. Okay, so there's that. You saw that one coming in. There's the other one. Doesn't even hardly look like it's moving. Ooh, go to. What do we got going on here? Oh, we got something in our... We just got to clear that out. That was something else that was there. Let's continue to graph. We can see that we're going to have to go out further because both of them came in, and we just got to go out further to see them hit. So I'm going to go to my window. I'm going to take my X max out to maybe 100. Okay. And now I'm going to graph that baby. So there's the one coming in. Here's the other one. Oh man, still hardly moving down. Just remember, it's decaying at 1%. So yeah, it's not a very quick decay. Let's go ahead and make this 1,000. Go by hundreds. You know what? We really don't need a negative y min. And let's just go up to 1 so we can see that 0.3 a little bit easier. Now let's graph that baby. So there's that 0.3 coming in. Hey, we now can see the other graph. Hit second trace. So second trace. Then look number 5. So you can just actually type in. You don't have to scroll down to it. Just type in number 5. And it'll take you there. Then you just want to hit enter on first curve, enter on second curve, and enter on guess. And there it is. This takes you 1,203.6 0.973. 1,203.973 years for that to decay. Okay, bacteria population doubles every 8 minutes. If the population begins with 1 cell, how long will it take to grow to 250 cells, 256 cells? So it starts with 1, it's going to double every 8 minutes. So this T is representing every 8 minutes. Remember that. The T represents every 8 minutes. The question is, when will this reach 256? Well, if you think about 256, okay, think about 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th, not 27, 2 to the 7th is 128, 2 to the 8th, 256. So 2 to a power is 256, 8. So T would equal 8, meaning it's got to take 8 8-minute segments. So if it takes 8 8-minute segments, the total time is going to be 64 minutes because it took 8 8-minute segments. 64 minutes total time. 26. Brad spent $1,200 on a recent credit card. Credit card charges 24.77% annual interest compounded continuously. How much will Brad owe the credit card company after 6 months if he makes no payments? So 1,200 times E, because it is continuously, to the 0.2477. That sounds like a full class to get. T, that's the equation for, and it says it happens it's an annual interest rate. So, if I look at 6 months, if I make it 6 months, that's half of a year, right? So I would take 1,200. Ooh, quit out of this, sorry. Take 1,200 second ln e to the power 0.2477 times 0.5. So he'll owe in half a year $1,358.22. Okay? How long will it take Brad to owe the credit card company $2,400? So let's go ahead and take a look at that. 2,400 equals e to the 0.2477 t. So 1,200 here, divide by 1,200. So I get 2 equals 0.2 e to the 0.2477 t. So now on my calculator, I go to y equals, clear out what I had. And here I'm going to put in 2. Down here I'm going to put in second ln. Then I'm going to put in 0.2477x. Remember, I did do some weird stuff with the window, so I'm going to go back to Zoom 6, which will take me to a standardized window. There's the 2. There's the other one coming in. Now just hit second trace. Go to number 5. Enter, enter, enter. And it'll only take him 2.7 years, 2.5 years, 2.798 for that to happen. Okay? Look at 27. You want to buy a car for $16,000. The dealership offers you a special loan at 1.75% annual interest rate with no payments for 60 months. Find the exponential expression for the balance of the loan. Find the amount due at the end of 60 months. So, for an annual rate, we would have $16,000 initial amount, 1 plus 0.0175 to the T, put in a 5 there, and you'll know. So 16,000, oops, quit out of this again. 16,000 parentheses 1 plus 0.0175 in the parentheses to the 5 years. I get, at the end of 5 years, total amount due will be $17,449.865 or 87 cents. Now, what if they compounded it monthly? The only thing that changes is now instead of this just being 0.0175, it's over 4, and that's to the 4t. So I can now come back to my calculator, second, enter, scroll back, and we're going to insert right here, second delete makes insert. I'm going to insert a divide by 4, okay? Then I need to insert a parenthesis here, so we want 5 times 4, which is 20. You could do just 20 if you want. But now my answer is $17,459.744. Okay? So now it says, what happens if they do it daily? That's what this part down here is going to say, is daily. Okay, well again, 16,000 doesn't change. 1 plus 0.0175 over the 365.25 to the 365.25t. Again, to figure out how much is due, I come back to my calculator, hit second, enter, scroll back, and instead of 4, I now need to change it to a 3. Then I need to insert some more numbers, 65.25. Okay, and then over here, I just need a 365.25 in the parentheses now. Ooh, but I didn't need that 4. So I'm going to delete the 4, hit enter, and the answer is $17,463 and 03. That's going to round up to 040. So there it is. Okay, done with that page. Try to get through some of these before I do one more video. Actually, I think I'll stop because it is kind of long. We'll go ahead and stop the video now, and I'll do the other ones here in just a second. So we'll stop the video. S3H. Through 27.